Hi everyone, my name is Ege. In this video, I'm going to show our new assignment. In this assignment, the goal is to train a neural network to generate text. And let's get started. Here is the cell one. First, I import all of the libraries I need. The most important ones are the PyTorch and the NumPy. PyTorch which is our deep learning library, and NumPy is for math operation. And in the cell 2, I download the book I choose for training. I pick the Alice in Wonderland from Project Gutenberg, which is free online library, and the book is saved as a text file on my computer. I only need to run the cell once. Cell 3 and cell 4, here I set my hyperparameters. The sequence length is 100. This means that the model looks at 100 characters at a time. The hidden dimension is 700, which is the memory size of the LSTM. Then I load the book and clean it. And I remove special characters and extra spaces, so the model only sees the clean text. All of these removals are in the cell 4. So cell 3 is for the hyperparameters, and cell 4 is for removing the special characters on the text file. Here is the cell 5. This is one of the most important parts. I split the book into input and target sequences. The idea is simple. If the input is Alice was talking and the target is like Lice was walking, shifted by one character, so the model learns, given these characters, what comes next. And I also use one hot encoding, which means each character becomes a list of zeros with a single one. This helps the model understand and the characters better. You can see the text file right here. All right, let's go back to the cell 6, which I'm gonna talk about the model. Here is the model. As you see, it starts the class called text generated LSTM. It has two parts. First part is the LSTM layer. This is a special type of recurrent neural network that can remember long patterns in text. It has a forget gate and a memory gate. And the second part of that model is fully connected linear layer that takes the LSTM output and predicts the new character. So I use 3 LSTM layers stacked on top of each other, which makes the model more powerful. And here is the cell 7 and cell 8. Those are the training parts. For each epoch, the model makes a prediction, and we calculate the loss using cross-entropy loss, as you can see in here. And for the optimizer, I used Adam. And after each epoch, the model generates a 20-character sequence, so we can see how it's improving. And as you can see in my results, early epochs produce random characters, but after around epoch 100, the model starts generating real English words. Let me show you one of the best one, like at epoch 131, the loss is 0.57, and the sequences, I wonder if I've been, which is really great. Let's go epoch 200. After we hit the epoch iteration to 200, the loss is dramatically low, and the sequences works and improve. So we don't know what we have before it, and it looks like it is proved. So it looks pretty great, and the loss is pretty low. I also plot the loss function. As you can see, there's a spike at the epoch 30, and it continues. And then after epoch maybe 48, 45, it starts to decrease. And around epoch 200, it hits 0.1123, which is pretty low. And I believe the guesses are pretty great. So thank you for listening to me. I hope you enjoy. Thank you.